Right, our next topic, which is our next actual extension topic. So, polynomials. So start off with a few definitions. So a polynomial, basically it's an algebraic expression in this sort of form, but let's define it a bit more. The first bit's a bit trivial. Pn cannot equal 0. The reason for that is because we define polynomials in terms of the highest power. And so if Pn was equal to 0, then we wouldn't have x to the power of n, which is the highest power. So it's kind of trivial, but technically Pn doesn't equal 0. But the other thing about the powers, we have to have an integer, but not only have integers, they have to be positive, well, or 0. You can't have a negative integer for a polynomial. Coefficients, well, we know that word anyway, is no different in polynomials. So the coefficients are the numbers that are associated with each of the pieces of algebra there. So the powers, I keep calling them powers, but I mean more formally indices or exponent is another word we use for powers. Now the degree of a polynomial, also known as the order of a polynomial. You'll see those two words sort of loosely used either way. Sometimes we'll say order, sometimes we'll say degree. And it's basically the highest power. So a quadratic, for instance, would be a polynomial of degree 2. The leading term, and this comes back to why Pn can't equal 0, because the leading term is Pn x to the n, so the term that has the highest power, as opposed to the leading coefficient, which is just Pn. So just be careful when you're reading the question that you're sure exactly what they want. If they want the leading coefficient, then it's just the number that they want. If they want the leading term, then it's the whole piece of algebra that they want. And a monic polynomial is when the leading coefficient is equal to 1. Again, some technicalities here. If it's equal to a number, usually we make it equal to 0, then it's called a polynomial equation. If it's equal to another pronumeral, then we call it the polynomial function. Technically, roots are solutions to the polynomial equation. And then we have this other term, zeros, and zeros are the values of x that make the polynomial 0. Well, if you think about it, that's exactly the same as the roots. But it's just technically, when we're talking about an equation, we talk about roots of the equation, but we talk about zeros of the polynomial. And if we're talking about the graph, then it would be the x-intercepts. All right. Which of the following would therefore be polynomials? All right, what about A? Hands up for A. Who wants A to be a polynomial? Because it's got the power of a half. Very good. No, can't have a half as a power. Oh, that's all right then. B. B doesn't have a fraction as a power, so we're okay with B. Why not B? Yeah. If we were to rewrite that one, we'd end up with x squared plus 3 to the power of negative 1. Can't have negative ones. What about C? C's all good. Yes, there's a fraction there. Coefficients are allowed to be fractions. There's no problems with that. Or D. Yeah, it's still a polynomial. A constant number is still a polynomial. It'll be a polynomial of degree 0. Because technically, I mean, we don't write it, but it's 7x to the power of 0. All right, let's have a look at this one. Have a look at that polynomial there. First question is it monic? And what's its degree? I'm going to give you time to process that. All right, let's see what we think. Is it monic? Oh, we got mixed opinions. I see some nods. I see some shakes. All right, we'll get to that in a sec. What do we think its degree is?
3.
3, 4. Okay. Well, if we were to expand the whole thing out, and those people that are saying, no, it's not monic and degree of 4, now you can see why. 8x to the power of 4 would cancel with the minus 8x to the power of 4. We've actually ended up with, yes, it is monic, but it's a cubic. It would be of degree 3. Degree 3. So that's the first bit.